Okay, recording. Now, these next ones, flipping the page, I assigned these two. So sine x is going to be opposite over hypotenuse. Cos x is going to be adjacent over hypotenuse. And tan x is going to be opposite over adjacent. So sine y is going to be 6.25 over 10.75. Cos y is going to be 8.75 over 10.75. And tan y is going to be 6.25 over 8.75. And then this question here, sine x is going to be 12.45 over 16.38. So this one's going to be 10.65 over 16.38. Cos x is going to be 10.65 over 16.38, which means this one's going to be 12.45 over 16.38. Tan x is 12.45 over 10.65, and the tan y is going to be 10.65 over 12.45. Questions, comments, concerns on any of those? Going once, twice, thrice, sold. Flip the page several times until you get to this one. I want to take values from you guys so I don't have to punch all these into my calculator. Sine 35 is what? Give it to me to 4 decimal places. 5736. Give me C. 2079. E. 6947. Cos of 46. Okay. Cos of 19. 945. Okay. Tan 35. Tan of 85. 4301. Cool. Questions about any of those issues? Do you disagree with any of them? Don't just assume that the voices that were all in unison are all correct. Okay, carrying on then. Angle A. What is the sine inverse of 0.75? 48.6 degrees. C. 9.8 degrees. E. Sorry, one more time. 41.4 degrees. G. 76.7. 73.7 degrees. Okay. I. 60.3 degrees. And K. Okay, does anyone disagree with any of those? Double check your work real quick. Rebecca, you figured it out? Okay, are we wrong or were you mistaken? You mistaken? Okay. Then jumping down here to number 5, I asked you guys to calculate the sine ratio of the angle, then use it to find the measure of angle y. What is sine y equal to? Over 18.27, which makes y equal to the sine inverse of this 55.8. Okay. Or 8.5. Okay. 55.9 degrees. Okay. Flip the page. I assigned you a whole bunch of these. Yep, this is on there too. Let's just go straight to the measure of angle P. How big is angle P? 23.47. I'll leave it to 2 decimal places. W is 10. W is 70.24. The measure of angle R. 42.19 degrees. Number 9, the measure of angle T. 38.94 degrees. Number 10. 30 what, sorry? 0.56. 11, angle K is how big? 54.5. Or 54.46. Okay. And then 12, calculating the sine, cos, and tan for angles A and C. Sine of A is 0.77. Cos A? Tan A? 0.19? 1.19? Okay. Sine C? 0.764. Oh, 0.64. Cos C? Tan C? Cool. Okay, does anyone want to see any of those done? Does anyone disagree with anything that has been stated? Nika?
I don't disagree. Could you do number 7 now? Wait. Yeah, can you do that? Because I've been doing it close and I don't know what it is.
Okay, so number 7 says to use the tangent ratio to find W. So W is this angle here. So for tangent ratio, which sides do we want? Opposite over adjacent. Good, I heard someone say it. So tan W equals the opposite side over the adjacent side. So tan W is going to equal the opposite side, which is 6.04 divided by 2.17. And I want you guys to actually show your work here. Then to find W, W is going to equal the tan inverse of 6.04 over 2.17. That's what you're going to shove into your calculator. And that should give you 70.24 degrees. Does that procedure make sense? Okay. Anybody else? Yes, sir. 8? Sure. So it says find the measure of angle R, and it gives us 2 sides. So what sides does it give us relative to angle R?
Hypotenuse and opposite?
We know this side is the hypotenuse, because it's across from the 90, and we know this side here is the opposite side from the angle that we're asked to find. So we have the opposite side, we have the hypotenuse. Which trig ratio are we going to have to use to find R? We're going to have to use sine. So sine R is going to equal the opposite side over the hypotenuse, and you solve it from there. Is that, you want me to go further, or is that good? Okay. Anybody else, 9, 10, or 11? If I'm hearing nothing, it means we're all good. Nobody is making eye contact with me, except for a few brave people. We good? We good? Okay, cool. Someone say something.
Yes.
Okay, we're good. Some of you are just like looking away and down, and I'm concerned, but that's okay. You got to tell me how you're feeling about this stuff eventually. Okay, so we're gonna brush over this next lesson. I want to get straight to the good stuff. This one, I don't need to spend as much time on this front page as I think it lends us to. This is just adding sine, cos, and tan to this idea here of bed mass. All of these operators show up just like a set of brackets would, just like every other operator we've ever used. So if I give us something like this here, sine 43 degrees plus 4, it's the same thing as if it looks like this, which is why it's so important in your calculators to actually throw down the brackets, like include them when you're punching things in. Because if you punch in sine 43 plus 4, depending on how your calculator is programmed, it might do sine 43, resolve that, and then add 4, or it might add them first and then do sine, depending on what and I don't know who programmed your calculator in. So you've got to make sure to include those brackets there. It gets handled just like brackets would, so it's the first thing you've got to do. So sine 43 happens first, and then you add 4. So what is sine 43 plus 4? 4.682. That's all it is. There's nothing really special here. Same thing here with number 5. It's exactly the same thing. Instead of sine, it's sine inverse, but again, it's just the opposite of sine, so it gets handled the same way sine does. What is number 5 here? The sine inverse of 6543 plus 46 degrees. 86.8, rounded to 87. Okay. That's all it is, nothing really special here. Multiplying and dividing get handled the same kind of way. Because sine is an operator, it needs to get resolved first. So 2 times sine 47, again, assuming you punch these things into your calculator, it'll do what it's supposed to do in the right order. So, and you're never going to have to do this without a calculator, because who knows what sine 47 is without a calculator. So 2 times sine, and this calculator opens up the brackets for me, is just going to do for us exactly what's written. What gets a little bit dicey is when we write it in the other order. So this guy here is 1.46. Where things get dicey is questions like 2 or 6, where you don't include brackets. So you want to make sure we put those in the right spot. For example, if I bring up cos, it automatically brings up my bracket before. So I'm going to go cos 80 times 3. It's going to apply cosine first, and then it's going to multiply the result by 3. So we get that. So again, nothing wild and crazy here. It gets handled exactly the way you'd expect BEDMAS to handle these things. Questions, comments, concerns? You are going, as long as you use your calculator properly, yeah. That's all I'm going to expect you to do. Absolutely. Cool? Then things get really kind of gross down here. You're going to get stuff that looks like this. But again, as long as we handle these things, again, you're just going to get a calculator to deal with all of these things at this stage. So as long as you put brackets down in your calculator in the right spot, it's going to do exactly what you tell it to do properly. So what do you get for number 1? Negative 3.07. Can someone verify that value for us? Can someone verify number 1? We're good? Negative 3.07? Okay. Number 2, what do we get? 2.75, which rounds to 2.08. Yes, give me the rounded to 2 decimals answer. Can someone verify? Okay, we're good. Number 3. Again, as long as we're shoving brackets in the right spot, we get what?
Negative 5.29.
Can someone verify? That is the correct rounded value to 2 decimal places. Someone tell me whether or not you got the same thing. And then I'm going to ask you number 4. You may as well punch that in right away too. 4 is an interesting one. What do we get? Can someone verify 3?
Yeah.
Which is good. Okay, number 4, what do we get?
7.2.
Sorry, Carolyn?
I got 7.8.
Sorry? Someone got 0.4? Okay, so let's take a look at how we punch this thing into our calculator. What's going on here? What's going on here? You are all smart grade 9s. What is going on here? Rebecca?
We most likely, a bunch of us just put it all in at once, and then
So how should it be entered into your calculator?
you do the equation on top, and then divide that answer by the bottom.
You could do it that way. So what you're suggesting is we do 4 cos 34, close the bracket, minus 10, and then I'm going to divide that thing by, how do I type the rest of this in? How do I divide it by all of the denominator?
Make it a fraction.
Well, I'm dividing here.
We can't see it.
Oh, sorry.
Put brackets in?
We have to put brackets in. We have to put brackets around everything that is in that denominator. So it's going to be bracket 2 sine 30, close that bracket, plus 5 tan 71, close that bracket, and we have to close the first bracket that we opened. So the correct answer is actually nothing that you guys got.
That's why I got no. Yeah.
Negative 0.43 is the correct answer here. If you wanted to punch this thing all in one long shot, you totally could. You just have to put brackets around the numerator. So it would be bracket 4 cos 34, close that bracket, minus 10, close that bracket, divide by, open a new bracket, 2 sine 30, close that bracket, plus 5 tan 71, close that bracket, and then close the other bracket.
So many brackets.
You can also just do it. No, you can also just do it in the fraction. If you put the fraction at the very beginning, you can
Yeah, you could do that too.
just put it in the fraction.
Sure. Not all calculators will do that though.
Oh.
So yeah, it's an exercise in making sure we put brackets in the right spots.
So many brackets.
Okay, but that's not abundantly useful. We're not going to use that a lot. What is going to be totally necessary and absolutely useful is things like this. Questions like number 1 and number 6 here. Questions like number 2 and number 7. So we've got a couple operations now that can be roped in to these trig ratios. So for a question like number 1, how would I solve that thing for x?
First figure out what sine 80 is.
Hands up. Rebecca, I see that hand.
First figure out what sine 80 is.
We don't have to do that first. 10 meet.
Times 4.5.
Yeah, to isolate for x, all that we really have to do is multiply by 4.5. And in fact, if we find out what sine 80 is first, we're probably going to have rounding errors. So the first thing you want to do is, multiply both sides by sine 4.5. It cancels on that side, and then we're going to get x equals 4.5 times sine 80, and then this thing can get shoved into your calculator. What is 4.5 times sine 80?
4.431.
2 decimal places.
4.43.
Can someone verify that that is correct? Okay. What about something like number 6? What would I do? X is not going to be allowed to equal what? Okay, now what? How do I isolate for x? Hands up, Rebecca. Rebecca's already said it. We're going to multiply everything by x. So if we multiply x here, we times x over here. My x's on the right-hand side are going to cancel. I'm going to get x times tan 19 equals 6. What am I going to do now? Divide, 10 meet said it, and Carolyn said it, by tan 19. Remember, we can't just divide by tan. We have to divide by, because this tan 19 is all one number. So we're going to get x equals 6 over tan 19, which is equal to what? None of you should just be sitting waiting for an answer. I want you guys actually working to figure these things out.
17.43.
Can someone verify that that's correct? Okay. Sorry? How did you get what? Which part? All of you should be, none of you should just be sitting there watching this happen. Every one of you should be punching these things into your calculator. Okay. We follow though how these things roll out. The reason for this, I'm not going to flip the page. I'm not going to assign anything from here. Flip the page again to this page here, lesson 4. I'm not going to assign any homework at lesson 3. The reason that this becomes necessary is because we want to start using trig for what trig is used for. Setting up right angle triangles and then finding missing lengths or missing angles depending on what we're asked to find. So if I give you something like this, and I say, okay, find me the missing side length of this. Well, there's multiple missing side lengths, but in this case, I've told you I want you to find side AC, which I've labeled X. How would I find this missing side, given the information that I have presented in the triangle? I've got this angle down here, and I've got this side 4 centimeters. What would I do?
So that would take the cosine of 50
Why?
to what's the ratio?
Why cosine?
Because you always, oh, it's not, oh no, I just thought C.
So what side, so if this is the angle we're given, what side do we have in the angle? We have opposite, right? So from here, this is the opposite side. And what side are we looking for in this triangle? Say it. Jay? It's a hypotenuse. So the sides that are involved in the problem are going to be the one that dictate how we proceed in the question. Given this angle, we have opposite, we're looking for hypotenuse. So now I'm going to set this thing up. Which ratio am I going to use to solve this problem? Sine, because I'm going to write this down here just to refresh here. This is probably something you're going to want to write at the top of all your pages. We want to use sine because sine references the opposite side and the hypotenuse. So let's fill it out. Sine of what angle? 50 is going to equal the opposite side, 4, over the side we're looking for, x. Remember, sine is a operator. It has to do something to a number, so we have to include the angle with it. Sine 50 equals 4 over x. So then to solve for x,
So sine 50 is 0.7.
oh no, don't. I'm going to really encourage you not to, do not, as much as I'll say it this way. How do I want to say this? To avoid issues with rounding, don't punch this thing into your calculator.
Okay, so sine.
You could. If you did, Carolyn, what would you get? 0 point.
7, 6,
Keep going.
6, 0, 4, 4, 4, 4, 3, 1.
And now we see that this thing is just a number. So to solve for x, what am I going to do?
Times
Multiply both sides by x. And
then divide by 0.76. 0, 4, 4, 4, 4, 3, 1.
0.766044443. If 1? Right, there's a 1 at the end. So then what is x going to be equal to?
5.2216291.
Okay, so your final answer can be rounded to 2 decimal places. 5.22. And that's a side length, so it needs the units. What are the length units on this question? Centimeters. Okay, so we could do it this way, but if you're going to take the sign of something in the middle of a question, you need to include all of the decimal places. Or you can recognize that this is a whole number and treat it as one object before you actually do any calculator work, which is the preferred way to do a problem like this. So we can skip straight from this to this procedure here. I'm going to multiply by x. It's going to cancel here. And I'm going to divide by what? Instead of 0.76604444331, I'm just going to divide by sine 50. So then you can say, well, that x is just going to be 4 over sine 50. And that is now the first point we pick up our calculator. What is 4 divided by sine 50?
5.2216.
Same thing. And that is actually the preferred way to do these problems. And then you don't run into rounding error. And it gets you guys comfortable with the fact that this whole object can move around, like we're adding subtracting, multiplying, or dividing one object. Cool? Next question. Let's do a question like this one. Using trig ratios, we want to find the missing side lengths. In this question, we've got 2 missing side lengths. So let's work it through. I'll do it with you guys. So I'm going to pick someone to make some decisions for us. I'm going to pick Rhea. The first decision is really easy. Rhea, do you want to find side x or side y first? Okay, Rhea said we're going to do x first. Rhea, you're off the hook. Rhea, you choose. Who gets to make the next decision? Carmen is make. Yes, for Carrot. I do. Ooh. Are you from Mr. Radness class? Ms. Jenna. I have the science ones. I'm not supposed to lend those to students not in a science class. So unfortunately, you're out of luck. Sorry. Nope, I've been teaching classes. I'll give them to you tomorrow. Okay, so Carmen, if we're finding side x, what information do we have that might be useful to our quest? Think about how we just did the previous question. Sorry, we have the 38 degrees. That is going to be useful because that's going to tell us how to label our sides. So we've got the 38 degrees. So Carmen, who's going to label our sides? Jennifer. I'd like you to label the sides involved in finding x using this 38 degrees.
X is adjacent and 5.6 is the opposite.
ADJ. And that guy right there is the opposite. Cool. I love it. So Jennifer, pick someone. Nika, which ratio am I then going to use if I have the opposite side and the adjacent side? If I have the opposite side and I'm looking for the adjacent side, which of these ratios am I going to use? I'm going to use TOA. And T stands for tan. Love it. So now I actually want to write this whole thing out. Tan, what's my angle? 38. Thank you, Chelsea. Is going to equal, now it's opposite over adjacent, so that's going to be 5.6 over x. Now to solve this thing, what do? Multiply by x, and at the same time I can divide by tan 38. So we're going to get that x is going to equal 5.6 over tan 38. And those of you who are punching things into your calculator, what do I get? Can someone verify that that is the correct value?
7.16?
Manrush says he's good? Okay, cool. So we found y. Congratulations. Go us. Which means the next thing we have to find is y. Because I said so. So, Acom. Was that you who gave me 7.17? Or was that Armand? That was Ty. It wasn't Ty, it was you. I heard a voice from this row. I didn't hear Ty's voice. It was you? Well, I was going to ask you to make the decision of who we're going to go to next. We're going to Ty next. Okay, cool. So Ty, I've drawn a line down my page here because there's actually 2 different ways now that we can find this missing side. Because what we've done now in the first part of the question is we found this side. We know this is now 7.17. I prefer 2. I like 2. So Ty, given the information we have in the triangle, what is one way you think we could find the missing side? No. Carolyn's going to give us the other one. Again, look at the same procedure we did for x. We have the opposite. Y isn't adjacent though. What is y? Y is hypotenuse. So we could use opposite and hypotenuse, which is going to be which trig ratio, Ty?
That's sine.
Thank you, Acom.
I knew it.
I think he was whispering. I do believe you knew it. You were just on the spot. So then let's fill it out. Sine of what angle? 38 is going to equal what? 5.6 over y. And now the procedure is exactly the same. I'm going to multiply y, divide by sine 38, divide by sine 38. My y's cancel here, my sine 38's cancel there. And I'm going to get y equals 5.6 divided by sine 38, which equals what? 9.10?
Yeah.
107, so 9.11. Is that what we got? Two decimal places rounded properly? Okay. So, was there any other way I could have handled that finding y business?
Why is it, what we learned, why is it 9.11?
Isn't it 107?
It's 9.10.
Yeah. And what's the next digit?
It's actually it's 9.095.
9.095?
So it's,
That's
yeah,
right,
so it's
that's
9.10 and not 9.11.
Oh. 9.095, so that's going to be 9.10. Okay.
Yeah.
Okay. So, we found side y using sine, because we have the opposite side and we're looking for the hypotenuse. Was there any other way I could have found side y in this triangle? Carolyn.
You could also use the cosine because we know the adjacent and hypotenuse because x is the adjacent to the
I could have used cosine, right? Because cos of 38 would have equaled the adjacent side here, which is 7.17, divided by y. Cool. I could have done it that way. Could I have done it any other way? Using ancient secret knowledge learned in middle school, perhaps. When I have two sides of a right angle triangle, what could we do? I could find, using this, a squared plus b squared equals c squared. You guys said you remembered this, kind of vaguely, some of you. Let's use it. Side C is always, in this formula, is always which side of the triangle? It's always the hypotenuse. So, let's fill it in. And then it doesn't matter, after that we identify the hypotenuse, it does not matter which one is A and which one is B. So let's call A 5.6, and we're going to square it, plus B, which is 7.17, we're going to square that. That's going to equal y squared. How do I get y by itself? What am I going to do? I have y squared. What's the opposite of squaring something? Square rooting something. So the square root of 5.6 squared plus 7.17 squared is going to equal y. And now this thing I can punch into my calculator.
It's 9.09. Well, you want to round it to decimal places?
Yep.
It's 9.10.
9.10 equals y. Well, isn't that fun? Are we cool with how this thing gets punched into a calculator?
Yeah.
All of you should be punching things into your calculator just to make sure you know how to use them. I don't want to move on until all of you have punched this into a calculator. I don't know how many times I got to say you should all be punching this in your calculator before you all get your calculators out finally. If you don't get 9.10, let me know so that I can do it. We good? Sahani, we good? Sukhjap, we good? Kinda, sorta. We're still punching. Olivia, is your whole back corner good? We're all good. Okay. Okay. Flip the page. What this is I'm gonna skip this. Flip the page. Skip this page. We can do extra practice if you need it. I want to get right to the good stuff. This is where this will finally ultimately lead. Yes, here we go. Solving triangles. I'm going to do one more last example with us as a class, and then I'm going to free you to find all of the things. So here we go. So, trig, more than most other units, allows you guys a lot more freedom to use these different tools. Instead of saying, use this hammer to build this house, use this drill to do this, use this tool to do this, this sort of says, okay, you got a whole toolbox now of 4 things, and I'm going to give you a 5th one right now. To find everything. Build me a house. Here's all your tools. Go. And you get to decide how you start and how you proceed. Which is why a lot of students get kind of persnickety about this particular unit. This is where things get irritating for some of you. What it means to solve a triangle, it means find all missing things. All angles, all sides. And that's all of the instruction you'll be given. And you will have to decide how this thing proceeds. So I'll do one example here. This guy here, I've got triangle ABC. We've got an angle of 65 degrees in the bottom left-hand corner. And we know that this one of the sides is 41. Does anyone have an idea of how you would like to proceed? Okay, so you're saying, so the first thing you did, we have 65 degrees here, and you're suggesting, Rebecca, that this side here is the opposite side. This is a good technique. Start labeling things you have relative to the angle you've got. So if that's the opposite side, which sides are we looking for? If they're not already labeled, we should label them with a variable. You said you wanted to use sine, which means what side are you looking at? Which is this side here. Let's give it a variable. What variable do you want to use for that side? X, sure, love it. So now in order to find X, you've already said we're going to use sine because we have an angle here. We know the opposite side. And side X here is the hypotenuse. So, I don't know, maybe it's helpful to write this down. SOHCAHTOA. Sine of 65 is equal to the opposite side, 41, over the hypotenuse that you've called X. So, let's solve it. What is X? How do I do this?
Multiply x by both sides.
Multiply X on both sides, okay, and then?
Divide the entirety sine 65 on
The other side, cool. So I'm going to get X equals 41 over sine 65, which allows us to find X, which is?
45.24.
Okay, cool. We have found our missing side. Did we have to do that side first? No? What could we have done instead? Or I'll say it this way. We found that side now. What do we do next? Sorry?
Find the adjacent
Find the adjacent side. So what you're telling me here is we've got the adjacent side, which is the bottom side. You want to give it a name, Gab? Why? Because I asked. Oh no, is why is the name? Okay, it's a bad joke. I'm going to use it as many times as I can. This is the adjacent side. So let's find y. Someone give me one way we could find y. Someone suggested cos. Okay, fill out, what is the equation for cosine? Y over, so cos of what? Keep going, Acom. Equals y over the hypotenuse, which we found to be 45.24. Okay, now to solve for y, what do I do? Actually, hold on. No, let's do it. Solving for y, what do I do?
Multiply by 45.24.
Okay, multiply by 45.24 on both sides. So now I have y by itself and in the numerator. So what's y going to equal? What's 45.24 times cos 65?
19.12.
Is that the only way I could have found y?
No, that's too low.
There are two more ways Carolyn claims. What is one of them?
Times the 10.
I could have used tan.
And you can
Hold on. Just give me one. Tan of what? Equals?
well, 45.24 over y.
Sorry, which side is opposite
Oh,
from 65?
over.
It's the 41
Oh, yeah.
over y. So instead of using, so Acom said, well, let's use cosine. Great, and then we used the side that we found. Or we could have used tan, because we have opposite and we're looking for adjacent. Is there another way we could have found side y? Carolyn says there was two ways. Someone else give me the third way. Rebecca.
C squared minus.
Hold on. Yep, Pythagoras. So let's start with the base formula.
A squared plus B squared plus C squared, but we only have C squared and then either A or B.
And we know side C. Remember, side C is always the hypotenuse. And the hypotenuse we already found to be how long?
45.24.
Okay, so I'm going to get 45.24, and I'm going to square that. That's going to equal, keep going, Rebecca. No, tell me what to do.
And then you would square it and then subtract either B.
Hold on. Yeah, let's give me values for A and B here. I want to write everything down step by step.
A squared could be the opposite, which is 41.
Okay, so you said A is going to be 41. So I'm going to square that, and then which makes side B, which one?
Y.
Y. It's going to be y squared. So then to solve for y, I'm going to subtract 41 squared on both sides. And then I'm going to take the square root of both sides. So I'm going to get y is going to equal the square root of 45.24 squared minus 41 squared.
So A equals 19.12. So y equals.
And all of these ways better give us the exact same value. Carolyn, already you did the a squared plus b squared?
Yeah.
It's the same value, 19.12?
Yeah.
Love it. Okay? So just because Acom said, oh, let's use cosine, doesn't mean we had to do what Acom said. We could have done what Carolyn said. We could have done what Rebecca said. It doesn't actually matter with which method. And when I tell you to solve for a triangle, you don't have to give me all of the methods. You just have to pick one and roll with it. I just want to show you what your options all are.
And now, can we
Hold on. Are we cool with what I just said before Carolyn jumps the gun here and finishes off our problem? Okay, Sukjap says we're good to go. So, Carolyn, you wanted to solve this. What are we missing still?
the angle?
We're missing the angle up top. Let's give that a variable. A. Okay, we can call it angle A. Let's find A. Carolyn, how many ways are there to find A? You are almost correct. There's actually a secret fourth way that I haven't shown you yet. So there's three, but you know three off the bat here. So Carolyn, how are you going to find, what's one of the ways to find A?
Use the sign.
We could use sine, because from angle A, which side is opposite?
Y.
Okay, so we want to make sure we label things. From angle A, side Y is opposite, and the hypotenuse stays the same. So if we're going to use sine, like Carolyn suggested, sine A is going to equal whatever Y was, this 19.12, opposite over hypotenuse, which we found to be 45.24. So then A is going to equal the sine inverse of 19.12 over 45.24, which is what?
Point
25 degrees. 0.00. Love that.
00104.
I love that. When those first two decimal places are 0, though, that's great. 25 degrees. Was that the only way we could have found A? Someone give me an alternative way to find A. I could use cosine. Okay, so what sides am I going to use then if I'm going to use cosine?
41 over 45.
Yeah. From angle A, the 41 now is going to be my adjacent side. So I could use cosine. Cosine A is going to use adjacent, which is 41, over the hypotenuse, which was 19.12. No, 45.24. So then A is going to equal the cos inverse of 41 over 45.24, which is going to give us the exact same value, 25 degrees. Is there any other way to find angle A?
Yeah.
What's the last way? If I've used sine and I've used cosine, then I'm going to be able to use, I'm also going to be able to use tangent. I was going to say tan A, dot, dot, dot.
And there's one more way.
There is one more way.
I know this.
You know this one? You remember?
Because a triangle, if you like to let it out, needs to be 180 degrees. So we can just do
Yes.
180 minus 65 minus 90 because wide angle is always 90. So you know.
Yes. Has anyone heard this before? Ty has heard it. Where? Manraj? Middle school? Okay. So let's record. We're going to catalog all the information we've got. We've got SOHCAHTOA, tools that I've taught you now. Then there's this thing, a squared plus b squared equals c squared, which is information that you were supposed to learn in middle school. For some of you, you didn't. That's okay. It's not always, you never have to use it. There's always ways around it, but it's something you definitely should learn. Now, we've got this last piece of information. Angles in a triangle always add. Underline always. Add. To what, Carolyn? 180. So I could use sine, cos, or tan to find that angle. Or I could say, well, the angles in this triangle add up to 180. And how many angles do we already know in this triangle? 2 of them. This one down here is, and this one right here is. So 180 minus 90 is 90, and 90 minus 65 is, sorry, 25. Right? 180 minus 90 minus 65, and if you want to shove that into your calculator, you're welcome to do that. But this is a real easy way to do this as well. And that's going to equal 25 degrees. So this is one example. I know there's a lot going on here, and you do not have to do all of what I've done. What I want you to see is that there are multiple ways, lots of options to tackle a problem like this. You just have to pick away and persevere. Comments, questions, concerns on any piece of this? Okay. If you gave up at any point and just said, I don't have any idea what's going on and stopped following, please let me know, and I will do what I can to assist you. This is where you've just got to persevere. You can do it. All of you have the skills, but yeah, I get it's June and you're tired. Just got to hang on. Here's what you're doing for homework. If you flip the page, I want you to do one and three are the same thing, so I'm just going to get you to do one.
Are we supposed to do it on another page?
Yes, you're definitely going to want to do this not on this page. We're going to get you to do two. We're going to get you to do four is the same as one. 3 is the same as 1. 5 is the same. 6 is the same. You're definitely doing 7. 7's a gooder. And I'm going to get you to do 10. And we'll save 11 and 12 for tomorrow. So there's only 4 questions I want you to tackle. Questions 1, 2, 7, and 10. What I'm going to say is this: the very first thing you should do is redraw these problems onto a separate sheet of paper, big. Draw them larger. One of my physics teachers always would tell me, draw out the problem, erase it, and then draw it bigger, because you almost certainly never draw it big enough the first try. So draw them big and find all of the unknown angles to the nearest degree and all of the unknown sides to the nearest tenth of a degree. I'm going to change that. I want everything to 2 decimal places. Everything rounded to 2 decimal places. Just those 4 questions. That's all you've got for me for homework today. And you've got like 20 minutes, so get started now. Work with your peers, ask me questions. Give her. Reference your notes. Yes, sir. You bet.